Hello friends, today I'm going to explain you about one of the several valves used in the hydraulic circuit. The name of the valve is tandem neutral type of direction control valve. The tandem neutral type of direction control valve is a 4x3 kind of DCV, which is 4 ports and 3 positions. Now, the application of this valve is in the hydraulic circuit whenever you want to stop the piston at any intermediate position between the inner dead position and the outer dead position of the cylinder. So in the circuits, wherever you want to stop the piston at any mid position and do some kind of work and then again actuate the piston and move to the inner dead center or outer dead center, then this kind of particular valve can be used. So first let us understand the circuit or the whole circuit which is made in the automation studio. Now this particular thing is the fixed displacement type of pump that will pump the fluid in this whole system. Now as you can see, this the lines that are made are the flow lines, which are simply kind of ducts from which the fluid will flow to several parts. Now this thing is a pressure valve which will actuate above the cracking pressure. So when the pressure reaches above the cracking pressure of this particular PRV, then the fluid is diverted from this pressure relief valve to the reservoir. This thing is the pressure gauge which will measure the pressure in the system. This thing is the reservoir which will store the whole liquid or whole fluid used in the system. This is a check valve which will permit flow in one direction and block the flow in other direction. This thing is the heart of the system. This is the tandem neutral type of DCV in our case, and in general any kind of DCV. As I earlier told, there are 4 different positions, likely 1, 2, 3 and 4, and 3 different positions 1, 2 and 3. So we will actuate these 3 positions separately and see what occurs later. This thing is a flow meter, which will measure the flow in the system. This thing is a double acting cylinder, which will actuate the different systems. This is the innermost position and this is the outermost position. So what happened in the system when we actuate 3 different positions? Let's see. This is the first position. As we can see, the arrow are parallel and counter side. So when we actuate this position, the fluid will directly go from this arrow to this part of the blank side of the piston, and it will extend the piston toward the further end. The remaining fluid on this side will directly go to the reservoir from the second arrow. When we actuate the third position, as we can see, the arrow are crossed. So the pump will pump the fluid in the line. The fluid will go directly to the rod end side, and which will retract the piston. The remaining fluid on the blank side will directly go to the reservoir from the crossed arrow. Now, main position, or the most important position, is the third position. As we can see here, the pump port is directly connected to the reservoir port, and both the actuation port are closed. So what happens that when we actuate this particular position, the pump will pump the fluid to the system, but the fluid will directly go to the pump port, to the reservoir port, and directly to the reservoir. So all the liquid pumped or all the fluid pumped by the pump will directly go to the reservoir. So no fluid flow takes place between this blank end side and rod end side of the piston. So the piston will stop immediately at any intermediate position whenever we actuate this particular position. So now let's see the actual working of this system. Now this particular thing is the simulation of the circuit. As we can see, the blue lines are the low pressure lines and the red lines are the high pressure lines. Now here the piston is right now in the innermost position. Now no more flow of fluid can take place. So the whole fluid is directed from this system to the pressure relief valve to the reservoir, and the pressure you can see is the highest here. Now we will actuate the first position and see the simulation how the fluid flow takes place. As we can see, the fluid is directed from this side to this line, and the piston is extended. Now, this line is the low pressure line, and this line is again the high pressure line. Again, if we actuate the third position, the system will go in the retraction mode, and the piston will be retracted. Now, the most important position is the third position. Now we will actuate the second position, that is the neutral position, and see what happens. Meanwhile, you can see here when the system is extending or retracting, the pressure and flow will be constantly changing. Now, as we actuate the third position, the piston will stop at any intermediate position while in the case of extending or retracting. So again we will actuate the first position and try to stop the piston at any intermediate position while by activating the second position. As you can see, the pump flow is taking place from the pump side to the reservoir side. So no fluid flow is taking place on the blink side or the rod end side. So the pressure at the flow again is 0 liter per minute, and the pressure is 2.39 bar, which is quite less as in case of the closed center valve. So we can achieve the low power consumption by using this kind of valve. This position is called the unloading position because the power consumption is reduced and it will waste much less energy than a closed central type of neutral DCV valve, because the pressure requirement is very less than compared to the closed central direction control valve. The piston will be held in this particular position as long as you actuate the second position, because the outlet port and the inlet port both are blocked, so no fluid flow can take place. Again, if you extract or retract, the valve or the piston will accordingly extend or retract as expected.